Good afternoon everyone. My name is Dr. Saurabh Roy. Today we will discuss one of the important topic in our module 2, that is power in AC circuits, power triangle and simple numerical related to this power triangle or powers. So whenever we will see the DC circuit, there are power is basically voltage into current we have seen, but in AC circuit there are different cases, or we can say different powers are there, or powers are categorized into different categories. So first we will see what are the different powers, which are available in the AC circuit. Those powers are actually real power, true power, or real power or true power, apparent power, and another one is called reactive power. So basically there are three types of power. So whenever three types of power, they are relate to one another. They are basically relate to one another and they form a trigonometric form. So this is called a power triangle and we call this power triangle. Okay. So whenever you see this particular triangle of power, so there are basically three types are there. One is the active or real or true power, which measure in watts, that is P equal to VI cos theta. So this power is also available in the DC circuit, but this two power is not available in the DC circuit. Okay, these two power, basically reactive power and apparent power, this basically observed in AC circuit. Okay. So now we'll see one by one. So what are the active, real or true power? Then we'll see apparent power and reactive power. So first we'll see the real power. So real power is also known as true or active power, performs the real work within an electrical circuit. We can perform, so they basically perform the real work. We can mention that. Okay. So that is also available in DC circuit as well as AC circuit. So real power measured in watts defines the power consumed by the resistive part of a circuit. So it defines the power consumed by the resistive part of the circuit. So if you see this, basically this is the power consumed by the resistive part of the circuit, basically resistance. Okay. So basically in circuit we have seen there are different things are there. One is resistance, inductance, or maybe capacitance. So the power consumed by the resistive part of a circuit is called the real power. Okay. So this power in AC circuit is same as the power P in a DC circuit. So basically we have seen in the DC circuit what is the power P, that is also same in an AC circuit, which consumed by the resistive part of a circuit. Now we'll see the next one. What is reactive power? So reactive power is the power consumed in AC circuit that does not perform any useful work. Okay, which does not perform any useful work, but it has a big effect on the phase shift between the voltage and current waveform. So it changes or it affects the phase shift between the voltage and current waveform. So that is called the reactive power in AC circuit or alternating current circuit. Okay. So here we'll see the reactive power is linked to the reactance produced by the inductors and capacitors. It counteracts the effects of real power. It counteracts the effects of real power. So that is called the reactive power in AC circuit. Reactive power does not exist in DC circuit. We can calculate the reactive power Q equal to VI sin phi, or its unit is volt ampere resistive. So mention. So here if you see the unit of reactive power, then we'll see the reactive power unit is volt ampere and resistive. Okay. So volt ampere reactive is the unit of reactive power. Okay. So it does not exist in DC circuit. It exists only in AC circuit. It counteracts the effects of real power. Okay. Now we'll move to the next part, that is apparent power in AC circuit. The product of the RMS voltage B applied to an AC circuit and the RMS current I flowing into that circuit is called volt ampere product and give the symbol as, whose magnitude is known generally as apparent power. Okay. So we are considering the apparent power, which is just the product of RMS value of voltage and applied to an AC circuit and same RMS value of current which flowing into the circuit. So this product basically is called a volt ampere product. Volt is related to the voltage, ampere that is the unit of current. So and it is symbolically represented by S, okay, and whose magnitude is generally known as apparent power. So this apparent power, it is a complex power. It is not equal to the algebraic sum of real and reactive powers added together, but instead of the vector sum of P and Q given in volt ampere. It is complex power that is represented by the power triangle. So there are three powers we have seen. First one is the real power, then reactive power and apparent power. So this reactive power and apparent power both are available in the AC circuit. Now if you observe the power triangle, you can see that there is a certain relation. This apparent power measured in volt ampere, reactive power volt ampere reactive, and active power in or real or true power measured in watts. So S, so there is the apparent power. There is a vector relation. Okay, there is no, that is not the algebraic sum of P and Q, but it is a vector sum. S equal to root over P square plus Q square. Okay, so this trigonometric relation is called the power triangle. Okay, so relation of three powers. So though all those three powers are available in the AC circuit, but the apparent power and reactive power is not available in DC circuit. Okay, clear? So now this the important question, power in AC circuit. So there are three powers. One is active, another one is reactive, another one is apparent, and another thing is the power triangle. So the relation between P, S and Q, which are in trigonometric relation, that is called the power triangle. Okay, and another important things you see here, B and I, all these things are for a AC case. All B and I, that is represent the RMS value of voltage and RMS value of current. So this also RMS value, and I also represent the RMS value. Okay, so root mean square. Okay, so RMS value of voltage as well as RMS value of current. Clear? Now we will see one of the numerical which is based on the power triangle, or you can say a simple reactance. Okay, so there are some data is given from resistance RL circuit, AC circuit, which consists of resistance as well as inductance. Okay, so this question is given ROL. Here resistance value is 35 ohm and inductance value is 180 millihenry. Okay, and voltage applied is 100 volt RMS and 50 hertz. So these things, you won't call that an inductance and resistance is connected to a 100 volt 50 hertz supply. Calculate the impedance of the coil, current, power factor and the apparent power consumed. Also draw the resulting power triangle for the above coil. So this is the example which is related based on power triangle, and we will try to solve the problem. So first we will write down the data given. What are the data given? The data given is resistance is 35, inductance L is, voltage V 100 volt and F frequency is 50 hertz. So first question is find the impedance of the coil. So how we will find the impedance of the coil? We know the formula is Z equal to root over R square plus XL square if inductance is there. We know the Z equal to R plus J XL minus XC. So that is the total formula, or it is in the complex form. But if you see the magnitude, then equal to Z equal to root over R square plus XL minus XC whole square. So here XC is not present, means reactance, capacitive reactance is not there. So only we will see the resistance and XL is inductance due to induction. We know the XL is 2 pi FL. So here L we know, L is 180 millihenry. That is, we can represent in 0.18 Henry, 10 to the power minus 3. And frequency F is given 50 Hertz and pi is no 3.14. So if you solve this particular XL, we are getting 56.6. And Z, the impedance, Z equal to root over R square plus XL square. R means 35, XL is 56.6. So the answer is 66.5 ohm. So that is the impedance of the coil. Okay, so instead of if capacitive reactance or inductance both are present, then Z equal to root over R square plus XL minus XC whole square. Okay, so these are the question. It may becomes okay in your upcoming exam. Okay, so next we will see impedance. After impedance of the coil, next we will find out the IRMS. Okay, so here voltage, that B given, which voltage is given, that is the RMS voltage. Here I mentioned BRMS. Okay. Now we should find out the value of current. Current is very easy terms because we know the B equal to I into Z. What is the V value? B equal to I into Z. So Z we know. Z is the impedance. Just now we calculated the impedance value. So we can find out the current value. Current I equal to V by Z. So what is V? V means 100. That is VRMS. And Z is the 60. So answer is 1.5 ampere RMS. So that is the current consumed by the coil. Okay. Now we'll see the next term, the power factor and phase angle. That is phi. So power factor and phase angle we should calculate. Okay. So power factor we know the cos phi equal to power factor, either we can calculate cos phi equal to resistance divided by inductance, or sin phi XL by Z, or tan phi XL by R. So these are the three. We can choose anyone. So we are choosing this one, cos phi equal to R by Z. Okay, because R value we know and Z also value already we calculated. So if you put the value, just divide 35 divided by 66, then we will get the answer 0.5263. Now this is the cos phi. Then phi, what is the angle? Phi equal to cos inverse 0.5263. So if you put those things in your calculator, then you will get the value 58.2 degree. That is the lagging. Okay, because it is the inductive reactance. Okay. Now coming to the next, we will calculate some power. So that is the apparent power consumed by the coil. So what is the apparent power? Apparent power is just multiplication of BRMS into IRMS. What is the multiplication? BRMS into IRMS. BRMS we know, BRMS equal to 100, and IRMS we calculated just now, B equal to IZ, B equal to IZ we calculated, I value I into Z. Okay, so I equal to B by Z. Okay, so already we calculated. Just now we put the value of I here, then that is 1.5 we already calculated. So the apparent power 150 volt ampere. It is a product of voltage and current. Okay, now if you draw the power triangle, so power triangle there are three components. One is the real power. Already we calculate the phi value 58.2 degree. So if you put P equal to B I cos theta, then we will get 79.1 watt. If you put VI sin phi, then 127.5 voltage ampere reactive, and another one is S equal to BI, then we will get 150 volt ampere. So this is called the power triangle. So here we are getting all those things: reactive power, then real power and apparent power. So this is the complete form of power triangle, and we draw the triangle and we put those values. So three things you should put. One is the all power values, and this the angle you should get. This angle you should put the value. Okay, and this angle we know, this angle is already 90 degree. Okay, so thank you everyone. So in the next lecture we will discuss some other points of our subject, fundamental of electrical and electronics engineering.